Welcome to Chapter 10, Conic Sections. These beautiful curves, circles, ellipses, parabolas, and hyperbolas are obtained when a plane intersects a double-napped cone. The Greek mathematician Apollonius named them around 200 BC. These curves have remarkable applications. Planetary orbits follow ellipses, satellite dishes use parabolas, and hyperbolas guide navigation systems. Imagine a double-napped cone, two cones joined at their vertices. The cone has a vertex at the tip, an axis running through its center, and generators, which are lines on its surface. When a plane cuts through this cone at different angles, we get different curves. The angle between the plane and the vertical axis determines which conic section we obtain. The four main conic sections depend on angle beta. When beta equals 90 degrees, the plane is perpendicular to the axis, giving a circle. When alpha is less than beta less than 90 degrees, we get an ellipse. When beta equals alpha, the plane is parallel to a generator, giving a parabola. When beta is less than alpha, the plane cuts both naps, producing a hyperbola. Degenerate conics occur when the plane passes through the vertex. When alpha is less than beta less than or equal to 90 degrees, we get just a point. When beta equals alpha, the plane contains a generator, giving a single line, a degenerate parabola. When beta is less than alpha, we get a pair of intersecting lines, a degenerate hyperbola. A circle is the simplest conic section. It's the set of all points in a plane that are equidistant from a fixed point, called the center. The constant distance from the center to any point on the circle is called the radius. Every point on a circle is exactly the same distance from the center. The equation of a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. When the center is at the origin, this simplifies to x squared plus y squared equals r squared. For example, a circle with center 0, 0 and radius 5 has equation x squared plus y squared equals 25. The general form of a circle equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0. From this form, the center is at negative g, negative f, and the radius is the square root of g squared plus f squared minus c. To convert to standard form, complete the squares for both x and y terms. Parabola is the set of all points equidistant from a fixed line called the directrix, and a fixed point called the focus. The focus must not lie on the directrix. The axis of the parabola is the line through the focus perpendicular to the directrix. The vertex is where the parabola intersects its axis. The standard equations of parabolas depend on orientation. Y squared equals 4ax opens to the right with focus at a0. Y squared equals negative 4ax opens to the left. X squared equals 4ay opens upward. X squared equals negative 4ay opens downward. The coefficient determines the direction, and the variable squared determines the axis of symmetry. The latest rectum of a parabola is a line segment through the focus, perpendicular to the axis, with endpoints on the parabola. Its length equals 4a, where a is the distance from vertex to focus. For example, if a equals 2, the latest rectum has length 8. This is the focal chord perpendicular to the axis. An ellipse is the set of all points where the sum of distances from two fixed points called foci is constant. This constant sum equals 2a, where a is the semi-major axis. The center is at the midpoint between the foci. Unlike a circle, an ellipse has two axes of different lengths. The standard equation of an ellipse with center at the origin is x squared over a squared plus y squared over b squared equals 1, where a is greater than b. The major axis has length 2a along the x-axis. The minor axis has length 2b along the y-axis. If b is greater than a, the major axis is vertical. Key ellipse properties. The foci are located at plus or minus c0, where c squared equals a squared minus b squared. The vertices are at plus or minus a0 and 0 plus or minus b. The eccentricity e equals c over a, and it's always between 0 and 1 for ellipses. The latest rectum length is 2b squared over a. A hyperbola is the set of all points where the difference of distances from two fixed points called foci is constant. This constant difference equals 2a. A hyperbola has two separate branches opening away from each other. Unlike an ellipse, the hyperbola extends infinitely in both directions. The standard equation of a hyperbola with center at the origin is x squared over a squared minus y squared over b squared equals 1. The transverse axis has length 2a along the x-axis. This connects the vertices. The conjugate axis has length 2b along the y-axis. Note the minus sign. This distinguishes hyperbola from ellipse. Key hyperbola properties. The foci are at plus or minus c0, where c squared equals a squared plus b squared. Note the plus sign, unlike ellipse. The vertices are at plus or minus a0. The eccentricity e equals c over a, and it's always greater than 1 for hyperbolas. The lattice rectum length is 2b squared over a. Asymptotes are lines that a hyperbola approaches but never touches. For the hyperbola x squared over a squared minus y squared over b squared equals 1, the asymptotes are y equals plus or minus b over a times x. These lines pass through the center and form an X shape. They're very helpful for sketching hyperbolas accurately. Eccentricity distinguishes the conics. For a circle, e equals 0, it's perfectly round. For an ellipse, e is between 0 and 1, it's elongated but closed. For a parabola, e equals exactly 1, the boundary case. For a hyperbola, e is greater than 1, it opens outward. The eccentricity measures how much the conic deviates from being circular. Watch out for common mistakes. Don't confuse ellipse and hyperbola equations. Remember the minus sign for hyperbola. Check signs carefully in standard forms. Use the correct formula for eccentricity, c over a for both, but c squared equals a squared minus b squared for ellipse, and c squared equals a squared plus b squared for hyperbola. Remember that a is always associated with the transverse axis. Key formulas to memorize. Circle, x minus h squared plus y minus k squared equals r squared. Parabola, y squared equals 4ax. Ellipse, x squared over a squared plus y squared over b squared equals 1. Hyperbola, x squared over a squared minus y squared over b squared equals 1. Remember the relationships between a, b, and c for each conic. Problem-solving strategy. First, identify the conic from the equation. Look for squared terms and their signs. Find the center, vertices, and foci using the appropriate formulas. Determine the direction of the axes. Sketch the curve using key points. Always verify your answer by checking that points satisfy the equation. Let's analyze the circle x squared plus y squared plus 8x plus 10y minus 8 equals 0. Group terms, x squared plus 8x plus y squared plus 10y equals 8. Complete squares, x plus 4 squared minus 16 plus y plus 5 squared minus 25 equals 8. Simplifying, x plus 4 squared plus y plus 5 squared equals 49. So center is -4, -5, and radius is 7. Analyze the parabola y squared equals 8x. Compare with the standard form y squared equals 4ax. We have 4a equals 8, so a equals 2. The focus is at a0, which is 2, 0. The directrix is x equals -a, which is x equals -2. The lattice rectum has length 4a equals 8. The parabola opens to the right. Conic sections have amazing real-life applications. Satellite dishes are parabolic to focus signals at the receiver. Planets orbit the sun in ellipses with the sun at one focus. Whispering galleries use elliptical shapes. A whisper at one focus can be heard clearly at the other. Cooling towers of power plants have hyperbolic shapes for structural strength. In this chapter, we learn that conics come from cone-plane intersections. A circle has all points equidistant from a center. A parabola has points equidistant from a focus and directrix. An ellipse has points where the sum of distances from two foci is constant. A hyperbola has points where the difference of distances from two foci is constant. Each has a standard equation and important properties. Thank you for joining Chapter 10 on conic sections.